Now, when do these tasks complete? How do I know that all these tasks are done? I've launched all these tasks. Suppose I want to do something at the end once all the work is over. I want to, let's say, print that, how many matrices did I inverse or something or the other, or maybe the sum of the elements that were added. So how do I know that the tasks have completed? Right, so tasks complete on barrier. So this is something that I've just added on this slide, right? So suppose this is not there, this no wait is not there. Okay, in that case, what happens is there is an implicit barrier at this point when the for ends. Right, all the threads proceed beyond this point only after they have completed their part of the for loop. So this is an implicit barrier that OpenMP has. Whenever you encounter a barrier at that point, if there are any tasks that have been created, all of them have to complete before you go past the barrier.
Is it only that brace, or if I enclose this in any other braces, even that will become a barrier?
No, this has nothing to do with braces. We saw earlier, right, hash pragma OMP single, even that has an implicit barrier, right? A lot of OpenMP constructs have an implicit barrier at the end. Master does not. Hash pragma OMP master does not have an implicit barrier at the end. But single, for, all of these have an implicit barrier. A lot of constructs have an implicit barrier at the end. Task obviously does not. So now, what happens if I put no wait over here? What happens if I say hash pragma OMP for no wait and I execute that same code? So sum was being printed here, right? It was coming out correct because there was an implicit barrier over here and all the tasks were completing. But in this case now I have added a no wait. So what's going to happen? This is what happened on an actual run. I found sum to be equal to 400. Some of the threads were still executing their tasks, right? One of the threads reached over here and executed this piece of code. So one thing I can do is I can explicitly say hash pragma OMP barrier here. Right? So even if I have no wait and I have put an explicit barrier over here, in that case what's going to happen? Again, all the tasks have to be completed on barrier, therefore I'll again get the correct result. Alright? So the important takeaway is that tasks complete on barrier. Here is a more involved piece of code that actually shows you what happens to private variables that are declared after the parallel region starts. Alright, so we are going to look at this variable tsum. Right, it's declared after the parallel region starts. And what do I do here? I print the thread ID, I print the address of tsum. Okay, I'm printing a memory location that points to tsum. Right, that's what this is doing, ampersand tsum. Alright, then I have this hash pragma OMP for, and again inside hash pragma OMP for, I again print address of tsum. So I mark here that I'm delegating this summation from this start to this end. And I'm again printing the address of tsum. And finally inside the task, I again print the same thing, the address of tsum. How do you differentiate what is what? So here I'm just printing tid%d, here I'm printing delegating sum, and here I'm printing task sum. Okay, so just look out for those indicators. So when I run this code, what do I see? In this particular case, there are only 2 threads. I ran this with 2 threads. So initially, these are the addresses of these memory locations. Obviously, they both had their own copy of tsum, so they had different addresses, right? Now, when I was delegating, so as you can see over here, this was being delegated by thread ID 1. So obviously, this address is same as this address, right? And these 2 were being delegated by thread ID 0. So these were the same as this address, right? Obviously, the same thread is accessing the same variable. But what happened inside the task? This is a completely new address. Well, in this particular case, what happened was that all 3 of them ended up being executed by thread ID 0, right? But if I had thread ID 1 executing something else, I would have seen another address, right? So I see another address over here inside the task, which is different from these addresses. Okay. Sometimes what I want to do is I want to access the variable of the delegator, right? The thread that invoked this task. I want to access that variable. So how can I do that? So all you need to do is you say #pragma omp task shared tsum. Okay, what that tells OpenMP is that you want whenever tsum is accessed inside this code, inside the task, it actually refers to tsum for the thread that was invoking this task. So it won't create a new copy. It will keep a pointer to that location of the delegator. So this is the run of this. So now what do you see? Thread ID had this address, thread ID 1, thread ID 0 has this address, and while delegating also you see the same addresses, and when the thread is executed, then also you see the same addresses. So thread ID 0 is the one which was delegating the work from summation 0, 0. That was executed over here, and you see that this pointer is the same as this pointer here. Similarly, thread ID 0 was delegating sum 1, 1, and you see the same pointer over here for sum 1, 1. And sum 2, 2 was delegated by thread ID 1, right? So the address of tsum was this, but it was executed on thread ID 0. But the address of tsum is that of the delegator. Okay? Just think of it as what do you do in #pragma omp parallel or at other places, right? What does shared mean? Shared means that whenever I access this variable in this region, I want it to refer to the same variable that is just before this region starts. So that's exactly what it's saying. The delegator is the one which was creating this task. So all it's saying is that this variable inside the task is going to refer to the same location that this variable was referring to just before the task started.
Could we go back to the no wait situation?
Yeah.
If the barrier wasn't there, then all threads would have printed sum, right?
Yeah. So I've just showed you one output. All threads would print sum. Some of them may end up printing correctly. One of the threads would definitely end up printing it correctly, the one which executes the last task, right? But all I wanted to show was that you can get incorrect results, right? In some cases, one thread may give you wrong results. This sum over here, right? This is actually defined outside OMP parallel, so it is actually shared. Again, it's printing these values. I see that all of them, whether I'm accessing it from the parallel region or inside the for or inside the task, all of them are actually pointing to exactly the same location. Okay? It's treated as shared. So all addresses are the same. And this is just demonstrating that you can create tasks from single thread using single, right? We already spoke about this in the context of a linked list.